Okay, great. So now that we're recording, we are good to go here. I don't really have any announcements other than the fact that, again, just as a reminder, there are no office hours today. I'm correcting the syllabus quite literally right after the end of this class. Office hours are Monday and Tuesday, so don't go by what the syllabus currently says, as we discussed that in classes before. So, moving to this, the most recent lecture was about how to distribute, how to multiply polynomials. So that's essentially what everything came down to for the homework. So the homework was just about distributing, making sure that you're able to do it with, binomials, trinomials, and then also on top of that, there were some certain special cases, or what I called blueprints, essentially things that you're going to see from time to time that are going to help you out substantially. We're going to review those in just a moment, but the biggest one that I harp on basically essentially all semester long is difference of squares. Difference of squares. And again, we're going to write all of them out, but who can just tell me just right off the bat what the general blueprint is for difference of squares when we're talking about binomials? So if we're starting with this, a plus b times a minus b, without doing any work at all, who remembers what this should come out to be? Anybody? Yoav?
Is it a squared plus a, yeah, ab plus ab, um, hold on, a squared plus ab plus ab minus ab,
Okay,
no, minus
so
bb,
you
minus
no no
bb, sorry.
yeah, absolutely. So the a squared part is right. And so we see that because if you were to do the foiling, right, if you were to do actually all the work here, we see that the first step that you would do with FOIL is first, right? So you do the first part of each parentheses, the first term. So a times a, which would give you the a squared, right? So Yoav is definitely correct there. Now, the next thing that you would do, again, if you were to do all the work, is you would do the outside. So you would have a times negative
Yeah.
b. And a times negative b would give you the minus ab or minus ba, whatever you want to call it. Again, we discussed this is going to be the same thing regardless. And then Yoav, help me out. What's the next one that we do if we're doing FOIL?
Plus ba minus b squared.
Okay.
Oh wait,
And
yeah, minus b squared. Sorry.
yep, minus b squared. Perfect. Okay. So, and now Yoav, what happens with my negative ba and positive ba?
They cancel. So the final answer is a squared minus b squared.
Perfect. So we get a squared minus b squared. This, guys, is difference of squares. So where we have a squared minus b squared, difference of squares. Where is the name coming from? Again, difference implies subtraction, right? If you have a difference of two numbers, it's a number being subtracted from another. Squares obviously are talking about the exponents, right? So the square here and the square here. So we have a squared minus b squared. You would have difference of squares. And this is all as a result of this very particular case where you have the same two numbers being repeated, and the only difference between them is the change of signs. So where you have a plus b times a minus b, regardless what those numbers are, they could be 7, 3, you might not know what it is, it could be a variable, x, for example, we're always going to get our answer in this form, a squared minus b squared, okay? We're going to come back and revisit this shortly because, again, there's two other ones that I feel like are very important. But let's jump into the homework first and see what questions you all might have for me. So, homework questions. Where did we get stuck? What was some of the more challenging parts about this homework? Everybody totally understood distribution. This was a super easy lecture. We were all good with
Oh,
this.
no, no, no. There were people raising their hands. Can we do question 55 and question 69?
55? Absolutely. Yeah. So we'll start with that, Olivia. And then Maggie, I saw your hand also just came up. So we'll jump to whatever question that you had next. Okay. So I'll double back to you. So 55, we have x plus 3/4 squared. Okay. And the directions say expand. Expand essentially just is another term for multiply. The reason that, you might not see it written as multiply and you might see it listed as expand instead is in this case where you have an exponent, right? So it's basically saying, okay, well, deal with the exponent and then obviously handle the polynomial multiplication. So what does this exponent tell us? What is this going to do for us? How do we, proceed here? What's the first step? Essentially, what I'm looking for here is, and Alicia, I saw your hand go up.
No, I have a question.
Sure.
Are you like gonna show us and like share your screen? Cause like, it's just like I just see people's faces popping up.
I am currently sharing my screen, and I'm looking at my other monitor here, and it looks like it's working correctly. Can I just
Yeah,
get a
it's
quick
working.
validation?
I can't see it.
Yeah, it's
Okay. I would just recommend just popping out of the call and hopping back in, and generally that fixes the issue, yeah.
Okay.
Okay, so again, just to get us started here, so we have x plus 3/4 quantity being squared here, right? So if you have something being squared, what does that tell you? If I had, for example, just, sideline this, what is 7 squared? Don't even tell me the answer, just, what does this actually mean?
7 times 7.
Yeah, exactly. It means you're going to take whatever number or value is underneath the exponent, and you're going to multiply it against itself the number of times that the exponent tells you, right? So in this case, 7 squared is equal to 7 times 7, right? You're just taking that value and multiplying it against itself twice because it's squared. So with that knowledge, what's our first step here with x plus 3/4 squared? What are we going to do?
multiplied by itself.
Yeah, exactly. We have a square, so we're going to take the entire piece that's being squared, so in this case, that's everything inside the parentheses, and we're going to multiply it against itself. So that's going to be x plus 3/4 times itself, so x plus 3/4. Perfect. Okay, so now at this point, we now have a binomial times a binomial, right? Binomial means 2 terms. So we have 1, 2 times another binomial, which is 1, 2, right? And whenever you have 2 terms times 2 terms, you can FOIL. FOIL, again, the mnemonic device, meaning first, outside, inside, last. Let's go ahead and write that out here. So FOIL, first, outside, inside, and last. And these, of course, just like we mentioned in the lecture, this is just relating directly to the positions of these values in the parentheses. So let's handle this one at a time. Let's do first, because obviously that's what we would start with. So just to get the ball rolling here, first, well, that's going to be the first position in each of the parentheses. So x times x. And what this gives us is x squared, right? X to the first times x to the first is x squared. Okay, what comes next? Who can help me out? Somebody other than Yoav. He's helped me out so much today already.
X times 3/4.
Yeah, perfect, Haley. So we're going to do outside. So outside means the x times the outside 3/4. So that's going to be, well, x times 3/4. You can't really simplify anything, right? So that's just going to be 3/4 x. So 3/4 x. Okay, perfect. And now what we just need to do is continue along, right? So we did first, we did outside, let's do inside. So inside, again, that's going to relate to the positions that are on the innermost of the 2 parentheses. So that's going to be 3/4 and x once again. So we're going to have plus 3/4 x, because again, 3/4 times x, can't simplify anything. And then last but not least, we just have to do the last part, right? So the last positions, so that's going to be 3/4 times 3/4. And again, when we're multiplying fractions, if you don't see it immediately, remember you multiply fractions by multiplying across, right? Just like we learned before. So that means that you're multiplying the numerators and then multiplying the denominators. So we have 3 times 3 gives us 9 over 16, right? 3 times 3 is 9, 4 times 4 is 16. So we get plus 9/16. And this here would be your final answer. I don't think my mic is working. I also keep raising my hand, but it seems like you can't see it. Yeah, I'm not really sure what's going on today. It seems like Teams might be giving us a little bit of problems. Alicia is having so similar issues, you can, you can absolutely, this is going to go up on YouTube. So if we're, encountering some issues where you can't see the screen or you can't hear me, for example, then yeah, you can just wait until it's up on YouTube. I'll try to get it up later today just because it seems like a couple of you are having some problems here. Again, I would just recommend just doing a reset and, hoping for the best. Maybe just fully resetting Teams and seeing what happens. Okay, so just to proceed here, to get back on track with this question. So we saw what happens when you can, foil, right? And we saw that we can foil because we had the two terms times the two terms, right? And foiling is essentially just another way of distributing. It's just the faster way of distributing, and it's also a mnemonic device to help you remember that you've done everything correctly, right? So there's also the alternate method, and we're going to double back to this. But before we, go back to this alternate method here, I just want to quickly review all the other blueprints that we covered, right? So we recently just talked about difference of squares. And one more time here, just writing it out, difference of squares, that's where we have one number plus a different number times one number minus a different number. And you're always going to end up with a squared minus b squared. Regardless what those numbers were, a squared minus b squared would be the answer here, right? There's two other, what I consider to be very important blueprints because it deals with binomials. So we're going to have the that's not an a plus b squared, and then also a minus b squared. So these are the two other ones that I feel like are pretty important to memorize if at all possible. But remember that even if you don't memorize them, you can always just do the work just by foiling, right? So again, anybody happen to recall what a plus b squared is going to give us?
Would it be a squared plus 2ab plus b squared?
Perfect. Thank you. Yeah, so we're going to have a squared plus 2ab plus b squared. And again, I'm not going to go through the process of foiling this out. So, feel free to foil it if you don't see where this 2ab is coming from. But again, the thing to keep in mind here is you're always getting this a squared. You're always getting this b squared term. And we're getting this middle piece as a result of the ab coming out twice from foiling. And again, it won't matter what these numbers are. If you have something in the form of one number plus a second number and it's being squared, you're always going to get this blueprint as a result. Every time, guaranteed. Okay? And then similarly, the only difference between a plus b squared and a minus b squared, well, the outcome should be incredibly similar, with the only difference being the sign of 2ab. So we're going to have this a squared here. We're going to have this b squared here. But again, the difference is now we have a minus 2ab. This should help you try to remember this because, again, the signs are going to match. Notice how we have an a plus b quantity squared, and the middle piece is positive. We have this a minus b squared, and the middle piece is now negative, okay? So the sign is going to directly follow from whatever, sign is inside the quantity being squared, okay? So why do I bring this up? Well, the reason for this is because we see that there's actually another way that we can approach the same question. So for this x plus 3/4 squared, what we did was we foiled it, right? We went through the process of foiling and then we simplified, right? And we can actually do one better simplification now that I'm looking at this, and I apologize for not taking this the next step further, but we have like terms, right? We have this 3/4 x and 3/4 x. So we can actually go ahead and add these together. Well, when you're adding fractions, because again, it's the same term, how do we handle this? Well, you just add the numerators because your denominators are already the same, right? We have a denominator of 4 for both of them, so you can just add the numerators, which would leave you with 6/4. And without skipping any steps here, we see that we can actually go ahead and reduce 6/4. So we get 3/2 x plus 9/16. So the different approach here that we can take is we can actually go ahead and apply what we learned here with this a plus b squared, giving us this blueprint of a squared plus 2ab plus b squared. All we have to do is substitute in the different numbers that we have for both a and b. So I'm just going to go ahead and erase all this. So erasing this, And I'm going to rewrite the blueprint that we're looking for here, right? Again, notice we have one number here. I'm going to call this A. We have another number here. I'm going to call this B. And now notice the sign between them. Well, the sign between them is positive, right? So we actually really do have this A plus B squared going on. So with that knowledge, we know that our blueprint should come out to be just like we described before, A squared plus 2AB plus B squared. So all we actually have to do is just substitute in the numbers that we have in front of us. So A, just like we talked about, well, that's going to be our X. So we know because we actually have an A squared, well, we're going to end up with an X squared. We know that we're going to have this B squared hanging around at the end. And what is B? Well, we're describing B to be 3/4. So we can actually just say then, okay, well, we know at the tail end here, we're going to have 3/4 being squared. So 3/4 being squared. And in the middle, well, again, what should we have? Well, we should have a 2AB, and what sign should it be? It should follow directly from the sign inside the parentheses, right? So we know we have a plus inside the parentheses, so we know we're going to have a positive 2AB. Well, the 2 is going to be for free. That's given to you, right? We know the 2 is going to exist here in this middle term, and then we just have to plot in the A and the B. The A, in this case, is our X, and the B, once again, is 3/4. So now let's just go ahead and simplify this. So I'm just going to erase this just for room. And simplifying this, there's no simplifications that we need to make to X squared, so we're just going to leave it as X squared. When we multiply our 2 times the 3/4, again, you just multiply the integer times the numerator of your fraction, right? 2 times 3/4, you take the 2 and multiply it against the 3 that's up top. So we end up with a 6/4 x. And remember how we handle an exponent on a fraction. We take the exponent and we apply it to both the numerator and the denominator at the same time, right? So this is the same thing as 3 squared over 4 squared, which, simplifying, gives us 9/16. And the last simplification that we can do, just like we did before, we know that 6/4 actually reduces. So x squared plus 3/2 x plus 9/16. So notice that we get the same exact answer here, regardless how you approach it, okay? If it makes more sense to you to FOIL, then absolutely FOIL. If it makes more sense to you to try to remember the blueprint here, this, the ones that we described over here, the A plus B squared, I promise you in the long run, as the questions get, increasingly more complicated, this will save you some time, especially the difference of squares one. It will save you an immense amount of time if you can start to spot the patterns. But if you can't, see the patterns immediately, or you need more practice at it, that's totally okay. Just resort to foiling, because foiling is not incorrect by any means. You're going to distribute, and then you'll get the same answer after you're done combining terms. Does anybody have any questions on this specific approach to, what question was this, 55? For the record, if you're trying to raise your hand and it's not working, just go ahead and just say something. I don't want to ignore you just because Teams is having some malfunctions. Okay, so we're all good with this one? Okay, let's go ahead and move on here. I believe Olivia also asked for 69, but before we get to that, Maggie, you also had a different question, right?
Yeah, the one we just went over, that was one I was going to ask about.
Question, the one that we just did? Okay, sure, no problem. So that means we can just jump right on to number 69 then, and we'll continue, okay? All right, so number 69, we have x plus y times x minus 2y quantity squared. Okay, so when we're looking at this one, notice the difference between this and the one that we just did. So the one that we just did was, just to write it down one more time, x plus 3/4 squared, right? We had a binomial being squared. And when you compare it to the question that we're about to do, notice here, we also have a binomial being squared. But there's also another binomial right over here that's going to be multiplied against that. So there's going to be essentially 3 different binomials here, right? If you're counting, you get 1 from the one underlined in red, and you get 2 from the one underlined in black, because you're getting, 2 from the exponent, right? So in total, there's 3 different binomials as opposed to the 2 that we had in the last question. So with that said, let's go ahead and try to figure this out. Your first instinct might be to try to multiply x plus y times the x minus 2y. So you might think, okay, well, this is pretty simple. I would just FOIL this, right? Do the x times the x, and then the outside, x times the minus 2y, so on and so forth, right? Can anybody explain to me why that might not be the best approach immediately? Anybody have any ideas why that might not work?
Because you have an exponent.
Yeah, exactly. And what did we talk about, in the first couple classes, right? Order of operations. Order of operations says, okay, well, before we do any multiplication, we have to handle the exponents, right? So we have this exponent that we have to deal with. And we can do it in a couple different ways. We can either just, hammer it out and do the distribution immediately, just like, we did with the previous problem, or we can just simply rewrite it. So simply rewriting this, just to save on room, I'm just going to put the equal sign underneath. So I'm just going to carry down the x plus y, and rewriting this just means, okay, I'm just going to expand the x minus 2y squared into x minus 2y times x minus 2y. And now it's a little more obvious that we actually have 3 binomials being multiplied against each other here, instead of just the 2 that, again, might have seemed instinctual to just, FOIL out. So we have x plus y times x minus 2y times another x minus 2y. You can go about this in different ways because we know that multiplication follows the same properties of real numbers regarding commutativity and associativity. So there's really no wrong way to approach this. I'm just going to go in the order that it's written, which means I'm just going to be multiplying first the x plus y times the x minus 2y. That's how I'm going to approach it. You can absolutely do the other version, which is multiplying these 2 first and then going back to the x plus y. Either way, you should arrive at the same exact answer. So handling the first multiplication here, we have the x plus y and the x minus 2y. Well, again, we're just going to FOIL, right? We have binomial times a binomial, 2 terms times 2 terms. So I can just FOIL, and I know that I'll come out with the correct answer. So FOILing here, if I can get somebody to help me out, I'm just going to do the first one. So x times x gives me x squared. What comes next?
X and 2y.
Yeah, so we have outside, right? So first, outside, inside, last. So outside is next. So we have the x and we have the 2y. But is it a 2y? What's this sign in front of it?
Negative 2.
Yeah, it's a minus, right? So as a result, we have to make sure that we carry that sign through. It's a negative 2y. We don't want to ignore that. So it's x times negative 2y, which tells us, okay, well, we know it's going to be negative. And then there's no simplifications that we can do, right? X times 2 times y is just 2xy. Can't do anything with it. We just leave it as 2xy. But again, we just note that it is negative because we multiplied a positive x times a negative 2y. Okay, so we continue moving along. So that was first, that was outside. Now we do inside. So inside, somebody other than Haley, help me out.
Are you able to just do can you just, with what you're doing right now, can you do it with the middle and the one that's to the right first?
So yeah, absolutely. Just like I was saying before, you can do the multiplication in either order. So you can either do the first binomial, which I'll leave underlined in red. So you can do the first one and the second one, or you could do the second one, which is blue, and the third one in green. It doesn't matter which order you do this multiplication. What matters more, and what definitely matters more to me, is that you understand how to properly distribute. And FOILing is just the method that we're using right now.
Okay, thank you.
Yep. Okay, so again, we did first, we did outside. So inside here is going to be the positive y times the positive x, right? Inside of those 2 parentheses. So that's going to just give us a plus xy. Okay, so we have a plus xy, and now we just have to do the last terms of each binomial. So that's going to be y times the negative 2y, which gives us minus 2y squared. Now remember, this is still all being multiplied by the x minus 2y, the one that's underlined in green. We still haven't handled that other binomial yet, that other multiplication, so that's coming very soon. We just have to see if there's any simplifications we can do inside the first parentheses just to make our life easier before we move on. So does anybody see a simplification that we can make just to, kind of reduce things?
The negative 2xy and the xy.
Exactly. Thank you, Nico. So we're going to have the x squared remains untouched. We have, notice, similar terms, right? xy and xy. The difference here is we have -2 of them here, and we have a +1 of it there. So we can definitely combine things. And when we have -2xy plus 1xy, there's going to be -1xy remaining. So I'm just going to omit the 1 and just say minus xy. And again, the 2y squared or -2y squared remains untouched, so I'm just going to bring that down. And x minus 2y, so this is the next step of the multiplication that we have to cover. Okay, so now we have, notice, 2 terms over on the right, but we have 3 terms on the left, right? So we covered this in the lecture, just a quick example of it, where essentially what you're going to do is you're going to split up your smaller one, which is your binomial in this case, the x minus 2y, and you're just going to take each piece of that binomial and multiply it against the entire parentheses. What I mean by that is, again, so we see we have an x and we have a -2y. So what I'm going to do is I'm going to take my x, put it over here, and I'm going to multiply it against this entire trinomial. So x times x squared minus xy minus 2y squared. And then, again, we have this minus 2y part. So we're going to rewrite this as minus 2y times, and again, I'm going to distribute this to each single piece, right? So what that means is I'm going to have -2y times the x squared, the minus xy, and the minus 2y squared. So I know this can get pretty long, pretty fast, but what we have to do is just, again, distribute to every single piece, right? So the first one isn't really that bad. We're just taking our x, multiplying it throughout. So we have x times x squared. So this first piece right here. X times x squared, well, that's not that bad. We just get x cubed back, right? Okay, somebody help me out with the next one. What's x times -xy?
It's minus x squared y.
Minus x squared y. Perfect. Exactly. The negative sign still stays because it's a positive times a negative. Then you just multiply the x times the x, which gives you the x squared, and the y just drops down with it, right? And last but not least, we have the minus 2y squared times x. Notice that there's no simplifications that are going to happen there, so we just have minus 2xy squared. So great, we just handled the first piece of this, right? We handled multiplying the x throughout. We distributed the x to every single piece of the trinomial. The next thing that we have to do is the exact same thing, but for the minus 2y. And once we do that, after that's done, we're going to see that hopefully there's going to be some like terms for us to condense. And once it's all condensed, that should give us our final answer. So first up, we have -2y times x squared. Again, notice that's not really going to simplify, so we're just going to have minus 2x squared y. Okay, moving to the next one, we have a negative times a negative, right? Minus times minus, that should give you a positive. So negative times negative, we know that this is going to be a positive term here. And we have 2, so we know the 2 is going to be carrying in. And we just have to multiply the y throughout that piece, right? So y times xy, well, the x is going to carry down, and we just have y squared. And the last thing that we have to do on the right-hand side here is distribute the -2y to the last piece. So that's going to be -2y times -2y squared. Negative times negative, again, we know this should be positive, so we know it's going to be a plus. We have 2 times 2, which gives us 4. And then we have y times y squared, which gives us y cubed, right? And now notice, again, we did all of our distributions, right? There's nothing else being multiplied except for, in each individual term. For example, this one, we see that we have 2 times x squared times y. But what I mean is we don't have any binomials times trinomials or binomials times binomials anymore. We just have individual terms all being separated by addition or subtraction. So now all we have left to do is just hunt throughout it and see if there's anything that we can condense. So just take it one piece at a time. Let's see, is there any other place in here where we have an x cubed? So I'm starting with this x cubed and I'm just looking throughout to see if there's anything else that I can combine it with. And the answer is no, right? There's no other place where there's an x cubed. So I know in my final answer, this x cubed is just going to drop down. Next up, we have this negative x squared y, right? So this one here. So I'm looking for another term that has an x squared and a y in it. So we look and we see and we spot one, right? We see, oh yeah, here's one. There's an x squared y right there. And that's the only term, right? This one, again, don't be confused. This is one single x and the y squared, right? So you have to maintain some sort of vigilance here to not get the terms confused. But again, you're essentially just playing a matching game here. So what we have here is, again, we're going to combine these two terms. We have a negative x squared y minus a 2x squared y. So that should leave us with minus 3x squared y. Okay, let's go ahead and keep going. So we have negative 2xy squared. And over here, we have a positive 2xy squared. And when we add these together, when we combine them, notice this is a negative, this is a positive. It's the exact same term. So when we add them, they're just going to cancel out to be 0, right? So those are just going to go away. And the last thing that we have to evaluate is this 4y cubed. We look throughout. There was no other instance of a y cubed for us to, play around with or combine it with. So we just drag it down. So our final answer is going to include that. So our final answer should be x cubed minus 3x squared y plus 4y cubed. And that's as far as we can take it. And that is this piece up here being fully expanded. Okay, so just to kind of go through the steps here one more time, what we did was we noticed that there was this exponent here that we had to kind of decompose. We had to break it up into its, the two different binomials. So we list the binomial twice because that's what the exponent tells us to do, right? It's itself times itself. So we write it twice, and then we just start with multiplying either of the binomials together, whether you do the red and the blue or the blue and the green, doesn't really matter. You're always going to get the same order either way, and you're always going to end up with one binomial remaining times a trinomial. So again, what I mean by that is you're always going to end up with something with 2 terms times something with 3 terms, regardless of the order that you take here. And we know how to handle that, right? What you do is you break up the smaller one and you distribute each piece of the smaller one to the entirety of the larger one, right? So we saw that we have this x minus 2y. That was the smaller piece here. So we're just going to take each piece of that, so the x and the negative 2y, and apply that towards the entire trinomial. And when we're done with that, we see that some terms drop out, some other terms condense, and that's all there is for that problem. Are there any questions with this, specifically with what we're doing, like the instructions regarding this? I want to make sure everybody's good with foiling and understands to look for similar terms and play that matching game at the end. We're good? Okay, great. So let me go ahead and clear this off. Any other questions with this particular homework? Anything else you guys want to go over? Okay, so with that being said, I'm just going to move on to some of the other prepared material that I had that's not on the homework. And then once we get through a little bit of it, that should be it for today. Okay, so for today, again, just one more time, just going to quickly remind you guys, because this is what I find to be the most important part of this lecture, and especially carrying forward for the rest of the semester. These are the big 3 that you're going to encounter. So we're going to have difference of squares, right? So again, a plus b times a minus b is the a squared minus the b squared. Then we have the other 2, which I'm actually just going to combine into one thing here. You might see this notation later on in the semester. You might also see this notation in other math classes, but I'm just going to write it as, instead of 2 different equations, a plus or minus b squared, where we have a squared plus or minus 2ab plus b squared. The plus or minus obviously will translate from one side of the equation to the other. So what I mean by that is if that's a plus between the a and the b, then it's going to be a plus for the 2ab. If it's a minus b, then just like we talked about before, the sign is going to match, so that's going to be a minus 2ab. Okay, so those are the big three that we have to try to remember. But there's also, we briefly discussed cubes, whether it was sum of cubes or difference of cubes. And I just want to give a little bit more practice on that just before, you know, we call it done with these so-called blueprints. Okay, so what I want to do is I want to look at this example. Let's say we had the following: x plus 2 times x squared minus 2x plus 4. And I said, okay, I want you to go ahead and expand this or multiply this throughout, right? And as we just looked at before with the most recent problem that we did in number 69, we know that this can kind of get a little bit messy, right? When we are looking at a binomial times a trinomial. Our solution to this is we take our binomial, we chop it up, and we apply each part of that as multiplication to the larger piece, right? So what it's going to look like is, okay, we have this x plus 2. I'm going to take the x and multiply it against the entire trinomial, so x squared minus 2x plus 4. That's a 4, I promise. I know it doesn't look like it. Plus 4. And then we also have this plus 2 over here. So plus 2 times x squared minus 2x plus 4. Right, and this is the same exact idea that we were doing before. And just to run through this, we see that we get x cubed minus 2x squared plus 4x. All I did was I took my x and distributed it to all three pieces, right? And then same thing is exactly what I'm going to do for the plus 2, right? So over here, we're going to have the plus 2x squared, and then we're going to have minus 4x plus 8, right? We multiply the 2 times the x squared, multiply the 2 times the negative 2x, and multiply the 2 times the 4. And that's how we get every single piece here. And we actually notice that a lot of stuff is going to cancel, right? We have this negative 2x squared and the positive 2x squared. So we know that these are just going to go away. We have this plus 4x and we have this minus 4x. So we see here that these are also going to go away. And what we actually end up with is x cubed plus 8. But we actually talked about this before, which helped it was just a little trick with exponents that helped us in a previous problem. What is 8? 8 really in secret is just 2 times 2 times 2, right? Which we know to be 2 cubed, right? So this is really x cubed plus 2 cubed. And we know this as a sum of cubes, right? So what is the point of, doing all this? Why did I go ahead and do all the multiplication throughout? Well, I want to show you that, again, there is technically the easier way if you can spot the pattern. And the pattern here for sum of cubes, just like we talked about before, is if you're dealing with a sum of cubes, so a cubed, plus b cubed, so that's where you have any two numbers. In this case, what we ended up with x and 2 as our bases for the exponents. But as long as you have any two numbers being cubed, you're always going to have the following for our sequence here. It's always going to be in the same pattern. So it's going to be a plus b times a squared. Sorry about that. Minus ab plus b squared. Right? And so there's actually a mnemonic device to help us out with this one as well. So sum of cubes and difference of cubes follow the same mnemonic device. And so for, distributing binomials, we had FOIL that helps us out. First, outside, inside, last helps us remember. And for sum of cubes or difference of cubes, we actually have one as well, and it's called SOAP. So SOAP, this stands for same, opposite, and always positive, which I'm just going to abbreviate as POS. Okay, so what this refers to is the signs of each term going forward, right? So we notice we have a cubed plus b cubed. This is very important to note the sign of what's going on between the cubes, right? So according to SOAP, this says, okay, well, we know it's going to be in the form of a and then some sign b. So in this case, we had a plus, right? So again, notice same sign. Okay, we're going to have the next set be opposite. So where we have this AB, notice we're going to have this negative between. And then the last term here, this b squared, is always going to be positive, right? Now, similarly, the difference of cubes. So again, where it gets its name, we have 3 cubes, right? Or I'm sorry, 2 cubes. So a cubed, b cubed, and difference implies subtraction between the two. So this, well, it's going to look very similar. We're going to have this binomial times a trinomial where we have this a, we have the b, the a squared, the ab, and the b squared at the end. And again, using SOAP, we can already figure out what this is going to look like. So SOAP tells us, okay, well, the first sign between them is going to be the same sign as the one that's currently between our cubes. So between a cubed and b cubed, there's a minus, so we know that there's going to be a minus here. We know then that there's going to be the opposite sign to follow. So this is going to be a squared plus ab. And then lastly, we know b squared is always positive. So using the mnemonic device SOAP, this can really help you out figuring how to multiply out a binomial times a trinomial if you can spot the pattern. And also, when we get to factoring, which is the next lesson, which goes up today, then this is also going to help you factor cubes when you see them. Okay. So going back to our question here, what we started with, this example, we noticed that we had this x plus 2. So again, if I just want to assign names to them, let's call this A, let's call this B, right? So I'm starting with an A plus B. And now notice that I have this A squared. Then I have the opposite sign, so minus, and then B and A, right? So I have the 2 and the X, which are B and A, so I have minus AB. And last but not least, we would have B squared at the end, right? And what was our b? Well, our b, just like we called it, was 2. So we would have the 2 squared at the end, which, yeah, that's our b squared. So notice that it follows in this exact same pattern. So we can actually forego all of the stuff that we did over here. We know just from sum of cubes and just from SOAP that, well, this should just actually come out to be a cubed plus b cubed, right? So we know then this should be x cubed plus 2 cubed, and we get the same exact answer, x cubed plus 8. Okay? Again, I know that this seems very abstract, and for your first time seeing it, it can be very confusing, but the idea here is the same as with binomials, right? If you can spot the pattern, you can make your life substantially easier. But if you don't see the pattern, that's totally okay as well, because notice that when you do out all the work, you get the exact same answer anyway, where we ended up with the x cubed plus 8. It just involves a little bit more work on your end to get through it because you have to do all the distributions and then all of the cancelings, or cancellations, sorry. Okay, so take a little bit to try to absorb this. I don't expect this to make sense at the first go, but with enough practice and enough repetition, this stuff actually does start to stick. So again, we'll see some more examples of this going on in the semester, but for right now, if you need to revisit this, absolutely do, and the video will be up on YouTube later today. Okay, any questions with anything else or anything that was just done here? Okay, so if there's no other questions, I'm going to go ahead and just let you guys go a couple minutes early, and I will see you all on Friday. And last thing, just remember your first quiz is on Friday, and the quiz will cover all the material essentially from this week. So it's the lecture that went into Monday, the lecture that went in today, and the lecture that is going into Friday. Okay, and don't be scared. You will still obviously have opportunities to ask homework questions because I give you about 20-25 minutes in the beginning of class to do so, and then the last 20-25 minutes are for the quiz itself. Okay, so that's it, guys. Have an excellent rest of your day, and I will see you all on Friday.
Thank you.
Thank you. Have a nice day.
Have a
Thank
great
you,
day.
Enjoy the rest of your day.